Remote meter reading system. Understanding and control. Good morning, everyone. In the previous classes, we learned meter reading of traditional electric meters. Have a basic understanding of meter reading. With the development of our communication technology and smart electric meters, a kind of remote meter reading system has entered our daily work and life. In the past, the traditional meter reading method was meter readers every month visiting thousands of households to read the meters. Currently, we will use the remote meter reading system to read the real-time data of electric meters. How is the remote meter reading system composed and controlled? We will through today's lesson, together with the students, understand it. Remote collection system mainly includes the structure of the electricity information collection system, the objects of the electricity information collection system, system logical architecture, system physical architecture, collection system communication channels, 5 aspects. Part 1. The structure of the electricity information collection system. The electricity information collection system is for collecting, processing, and real-time monitoring of electricity information system. It realizes automatic collection of electricity information, metering, anomaly monitoring, power quality monitoring, electricity analysis and management. Related information release, distributed energy monitoring, and information interaction of smart electricity devices functions. Objects of electricity information collection system mainly includes A, B, C, D, E, F. 6 types. Among them, large special transformer users are type A, which refers to electricity users with a capacity of 100 kilovolt ampere or above. Special transformer. Medium and small special transformer users are type B, which refers to electricity users with a capacity of below 100 kilovolt ampere. Special transformer, 3-phase general industrial and commercial users. Type C, low voltage, 380 voltage commercial small power office. Non-residential, 3-phase electricity users. Single-phase general industrial and commercial users. Type D, low voltage, 220 voltage commercial small power office. Non-residential, single-phase electricity users. Residential users. Type E, whose electricity use is residential. Public distribution transformer assessment metering points. Type F, used for internal assessment. On public distribution transformers for internal assessment, metering points, other gateway metering points. Data collection items, collection intervals, collection methods can be referred to. This is the logical architecture of the electricity information collection system. The electricity information collection system is logically divided into the main station layer, the communication channel layer, the collection equipment layer. 3 levels. Since the electricity information collection system is integrated into the marketing SG186 application system, so data interaction is unified by the marketing system with other application systems through interfaces with the other application systems. Second, among them, the main station layer is further divided into marketing collection business applications, the front-end collection platform, and database management. 3 parts. Business applications. Implement the system's various application business logic. Data collection is responsible for collecting the terminal's electricity information and responsible for protocol parsing. Control execution is for the terminals with control functions to perform related control operations. Front-end communication scheduling is for various remote communication methods with the terminals to manage and schedule the communication. The communication channel layer is the link between the main station and the collection equipment, provides various available wired and wireless communication channels for the main station and the terminal's information interaction, provides link foundation. The main communication channels used are fiber optic private network, fiber optic private network, GPRS CDMA, wireless public network. Fourth, the collection equipment layer is the information-based layer of the electricity information collection system. It is responsible for collecting and providing the original electricity information of the entire system. This layer can be divided into the terminal sublayer and the metering equipment sublayer. For the low voltage centralized reading part, there may be various forms, including concentrators, electrometers, and concentrator, collector, electrometer. The terminal sub-layer collects information from user metering equipment, processes, and phrases related data, and it interacts with the upper main station. The metering equipment layer performs energy metering and data output functions. This is the physical architecture of the electricity information collection system. 1. The electricity information collection system physically can be divided in deployment location into the main station, communication channels, and collection equipment, 3 parts. Among the main station part forms an independent network with other application systems and public communication channels using fibers for security isolation to ensure the system's information security. Regarding system security construction, it follows the security protection technical specification. Second, the physical structure of the main station network mainly consists of marketing system servers, including database servers, disk arrays, application servers, front-end collection servers, including front-end servers, workstations, GPS clocks, isolation devices, firewall devices, and related network devices. Third, communication channels refer to the remote communication channels between the main station and the terminals, mainly include fiber optic channels, GPRS, CDM wireless public network channels, 230 microhertz dedicated wireless power channels. The networking situation and the characteristics of the channels refer to the subsequent communication channel section. Fourth, collection equipment refers to the terminals and the metering equipment is installed on-site, mainly include special transformer terminals, remotely transmittable multifunctional meters, concentrators, collectors, and electrometers. The structural design, functions, and performance of the related equipment refer to the subsequent terminal equipment section. Collection system communication channels mainly divided into remote channels and local channels. Among the remote communication network completes the data transmission communication function between the main station system and the on-site terminals. Mainly involves communication from the on-site terminal to the main station. The distance is usually far, ranging from 1 to several hundred kilometers, so it is called a remote channel. Local channels. The main difference between local channels and remote channels is the communication between the on-site terminal and the on-site electrometer. The transmission distance is generally less than 1 kilometer. Currently, the remote communication network suitable for the electricity information collection system mainly include the power distribution fiber optic private network (GPRS) CDMA, 4G and other wireless public networks, the 230 microhertz load management dedicated wireless private network, and medium voltage power line carriers. These 4 networks here we introduce the application of wireless public networks in practical work. Fiber optic private network refers to the construction of the power users electricity information collection system based on the overall plan. It is a type of internal communication network of the power grid company using optical fiber as a channel medium. It covers the entire network of distribution lines. Fiber optic communication uses light waves to transmit information through optical fibers. Currently, the internal backbone network of enterprises mainly use fiber optic private networks to meet the continuous application needs of substations and the entire system. Wireless public network communication refers to the application which electric metering devices and terminals access to the wireless public network through wireless communication modules, and then access the main station collection system through a dedicated optical fiber network. Currently, there are three main types of wireless public network: GPRS, CDMA, and 4G. They basically cover all inhabited corners of the country. Most places have GPRS data communication networks. They have characteristics such as low construction investment, wide application range, flexible network construction, and convenience. The second type of communication channel is a local channel, mainly used for communication connection from the on-site terminal to the meter. High voltage users install special transformer terminals in the distribution room to access the meter nearby. Using RS485 connection in low voltage users, there are a large number of power users on the public distribution transformer with small electricity capacity and scattered metering points. To control the cost of information collection within an acceptable range, it is necessary to use a low-cost local channel method to concentrate the information and transmit it remotely to the main system. In low-cost solutions, the way local communication channels are implemented mainly includes power line carriers, both broadband and narrowband, and RS485 buses, while considering short-distance wireless and other technical solutions as a supplement. Comprehensively consider factors such as system construction, reliability, and operation and maintenance. Applications can be selected according to the specific situations and technical solutions. The above is the basic structure of the electricity information collection system. I hope you all have a basic understanding of remote meter reading. The next class will introduce installation of debugging of the collection of terminal equipment.